everyone, this is my first video of going through some thermo questions that I think is somewhat difficult and would be pretty good for exam prep. Okay, so this is the question I'm going to do today. An ideal gas expands adiabatically from a state with volume. Why am I reading this out, y'all? You guys can read it. I'm not reading this because I'm supposed to be sleeping right now. So there's this, rule that you can use, more like a formula, that states that TV, or T is temperature and V is volume raised to the power of 2/3 equals a constant for adiabatic expansion. And you can use this formula to solve this question. First, I'm going to show you how I would solve this question knowing this pretty useful formula that's, I don't think, mentioned in the formula booklet. You have to kind of derive it yourself. I'm first going to solve the question and then I'll prove this equation to you guys. Okay? So T1 V1 raised to the power of 2/3 equals T2 V2 raised to the power of 2/3. T1 is 560K. Oh, never mind, sorry. 560K times 2.8 times 10 to the power is T2. I'm going to leave this as a note because that's what we're trying to find here. Volume, temperature. So I'm going to move this all over to one side except for T2, which I'm going to leave it here at the right hand side. 2.8 times 10 to the power of minus 3 2/3 is 4.8 times. And if I calculate this, I am going to get 390.96 Kelvin, which is approximately, let me check if I'm right. Yep, I am pretty much right. Alright, now that we've got the answer, we're going to derive this formula. So, from the formula booklet, we can tell that, deriving TV to raise to the power of 2/3 is a constant. So, from the formula booklet, we can see that PV to the raised to the power of 5/3 is a constant. And remember, this is, oh my gosh, oh my bad. Okay, I'm just gonna write it in black. Only for adiabatic expansion. Always remember this. This only applies for adiabatic expansion. Everything else, well, not really everything else, but if temperature remains the same, for example, for isothermal expansion or contraction, we just use this PV equals C formula. But for adiabatic, since the temperature is changing, we use this specific formula. Okay. Now, we know that because a gas is expanded or contracted in an adiabatic system, is still going to be assumed as an ideal gas normally. We're going to assume that this is an ideal gas. So PV is nRT. And P is nRT divided by V. So, if we substitute P as N times R times V over V, N times R times T over V, we can write this as nRT V times V to the power of 5 over 3 is C. And if we simplify this further, we can say that nRT V to the power of 2/3 is C. Remember, number of moles times the gas constant is going to be a constant. So I'm just going to say nR is some other constant, which I'm going to write as C2 TV 2/3 equals C. And I'm going to divide C by C2, which is just going to give another random constant. So TV to the power of 2/3 is C, a constant. And there you have it. So if you see something that says adiabatic expansion gives you temperature and volume only, then try to use this formula.